In this video, we will learn about the modeling of data within organizations and SQL, which is a language that allows us to take that model and make it real. A data model is a graphical description of the data within the organization and the relationships between different elements of that data within an organization. As it expresses relationships, the name of the model that we will be learning about is known as the relational model. If you remember, the relational model was developed in the 1970s by an individual known as Codd. SQL stands for Structured Query Language. It is a language that allows us to take that data model and actually instantiate it in the form of tables and rows in an actual database. SQL is both a data definition language and a data manipulation language. By data definition language, I mean that SQL allows us to describe the data, allows us to create tables, and establish various attributes and characteristics of these attributes of the tables. As a data manipulation language, SQL allows us to extract data from a database. It allows us to manipulate that data and then present that data to anyone that might be interested. As I mentioned earlier, the relational model was developed by an individual known as Codd in the 1970s. In Codd's relational model, he described this thing known as a relation. A relation is analogous to a table or a set. A table consists of rows and columns, and each row contains a separate instance of data. A relational database, consequently, is a collection of relationships or a collection of relations, and consequently is a collection of tables. Tables themselves are collections of facts or things that we want to know about. In Codd's relational model, Codd has a few key terms that he uses to describe different elements of the model. The first term he introduces is that of an entity. An entity is something in the environment that we want to keep track of. An entity is represented by a rectangle, and an instance is a particular occurrence of an entity. For instance, if we take the university system, a student might be an entity that we would want to keep track of. Each individual student is an instance or a particular occurrence of the generalized student entity. Attributes are facts that we want to know about the entity or discrete data elements that describe the entity. Now, obviously, attribute names must be unique as we don't want to be confused when attributes have the same name. Attribute names must also be meaningful, and by this I mean that when we use an attribute name, that attribute name should be understood by others that might also see and share that data model. Data models are graphical descriptions, and individuals and organizations oftentimes collaborate over them. Consequently, attribute names and entity names must mean something both to the individual creating the data model and also to individuals who might see and use that data model. The third important concept in Codd's relational model is that of identifiers. Every instance of an entity must be uniquely identified. Take, for example, a student at a university. How does the university distinguish one student from another student? They assign the student a unique identifier. An identifier can be an attribute or a collection of attributes. For instance, again, working with the student example, one can think of the last name of a student as an attribute of the entity student. However, last name would be an inappropriate identifier as many students might have that same last name. The purpose of an identifier is to uniquely identify each student. Last name as an attribute would be an inappropriate identifier. Identifiers can be created if there is no obvious attribute. To signify an identifier in a data model, one needs to denote the identifier with a leading asterisk. Here are a few terms that you might actually hear when we are working with a relational model and a database. A database is a collection of related files or tables. In the language of code, a database is a collection of relations. Records, or instances of an entity, are rows in a table. Each row is one instance of data. Fields refer to columns or attributes of the table. Columns provide information about the finer details of an instance of an entity. While one can create data models on pen and paper and use the notations, rectangles, and so on and so forth to create the data model on the piece of paper, MySQL Workbench offers us an interface to create data models in addition to writing SQL queries. When we open up MySQL Workbench, we are introduced to this interface. On the left-hand side of MySQL Workbench, you will see three icons. The second icon, which has boxes linked together by lines, is the one that allows us to create data models. Now you will notice that I already have some previously created data models. Please ignore those. To create a new data model, one needs to click the plus sign right next to models. This brings us to this interface that allows us to make data models. Now, the first thing we need to do is double click on Add Diagram, and you should see the following screen. If you do not see the following screen, feel free to close the EER diagram and double click on it and reopen it. Now on the screen you see the center line over here, and so this is the space that allows us to create a data model, and we have multiple sections or multiple pages. So we can create pretty large data models over here. Now, some of y'all might have a drawer that opens up on the left-hand side or on the right-hand side. Those drawers can be activated and deactivated by these icons right here on the upper right corner. Keep clicking on the left-hand side icon, one notices the drawer on the left-hand side. Clicking on the right-hand side icon, one notices the drawer on the right-hand side. I'm going to leave the left-hand side drawer open and keep working. To start off with, let us use MySQL Workbench to create an entity. To do that, one needs to click on this icon right here. The icon, if you hover over it, says place a new table. Click on that icon and come to the checkered area and press down on it. One sees this box show up. Double clicking on this box opens up this drawer on the bottom. Now, if the bottom drawer is occupying too much space, one can reduce the amount of size the space takes up by working with your cursor and these sizing bars. What we have just done is we have placed or created an entity in our data model. The name of this entity is table 1. We want to rename that. Let us, for instance, create a student entity, students at the university. And so the entity has to receive a name, in this case, student. One can also have the plural of this, as there are going to be many students, student instances in this entity. One can also refer to it as students. It's a personal choice. I shall prefer the singular instead of the plural, so I'm just going to refer to it as student. Now, in the bottom drawer, one sees column, data type, and a variety of other checkboxes. The first thing that every entity needs is an identifier. In this case, we can create an identifier for this entity student, and I'm going to create the identifier student underscore ID. Now, please note, I am going to start all my attribute names in lowercase, and after that, I'm going to follow the camel case convention. The camel case convention is where the first letter of the word is always in lowercase, and every word that comes after that starts with a capital letter. Please also note that none of the attributes are going to have any spaces in their names. None of the tables or entities are going to have spaces in their names either. So, I have created a column called student ID, and you will notice that there is a key next to this. This key, right here, is also known as the primary key. Identifiers are primary keys because the purpose is to identify each instance of an entity uniquely. One will notice that the box for PK is checked. PK stands for primary key. One will also notice the box for NN is checked for this attribute. NN implies it's not null. Primary keys can never be null, and so the primary key is unique and it can never be null. These other boxes we shall learn as we go on. Please note also that the data type of this column is set to integer. One can change that. One can have a variable character, one can have decimals, one can have a variety of other data types that are for these attributes. In this case, we can just leave it as integer, or we can select variable character, and you are prompted with a cursor in there asking us how many characters is the student ID going to be, and let us say that it's going to be 10 characters long. We can now start creating other attributes. For instance, a student has a first name, and please note I'm again using camel case, and the data type over here is varchar or variable character, 45 characters long. I don't have to use up all 45, but it can go up to that size. I can have another attribute called the last name, also variable character, 45 characters long. I can have the student GPA, and for instance, the GPA can be a decimal, and as it is a decimal, I'm going to have it be 3 characters long with 2 of those characters as after the decimal point. This allows me to go from 0.00 to 9.99 as the student GPA. I have added another one called major, also again variable character, 45 characters long. So as you can see, MySQL Workbench allows us to create entities, attributes, specify the data types of those attributes, and any specific characteristics we want those attributes to have, such as being the primary key, setting it to be not null, so on and so forth. MySQL Workbench is a very useful tool to allow us to create pretty complicated data models. This very first data model that we've just made is a single entity data model. Over the next couple of weeks, we're going to learn about adding more and more entities and establishing relationships between those entities. One can save these data models by clicking on the file icon and saving your model. If you save your model, it saves as an MWB file, Microsoft MySQL Workbench file, and you can save it in any location and reopen it as and when you choose. While a data model is a useful way to represent what the data is within an organization and an entity is, we actually need to go ahead and take that representation and make it real and have it present within a database. Consequently, we need to have a table representation of that entity. There are a few rules for this process. Each entity in a data model becomes a table. The name of the entity becomes the table name, and each attribute of the entity becomes a column in that table. The identifier of the entity becomes the primary key of the table. We will adhere to these rules as we make tables corresponding to entities in our data model. Once we have a data model, we would like to actually take that data model and make it real. To do that, we have to rely on SQL. SQL again stands for Structured Query Language, and it allows us to create tables based on entities that are present in the data model. To write SQL, one needs to connect to a database server. The server that we're going to connect to, we have previously set up within MySQL Workbench. Please go ahead and connect to that server that is present on campus. Again, please note that one needs to be connected to the Cisco VPN if one is working from off campus before one connects to the server. This is going to ask me for a password. I'm going to type my password in. And I am now connected to the campus server. On the left hand side, I am going to see the databases that I have access to. Please note that you are not going to see this large of a list. You're going to see a smaller list. Before we start creating tables for entities, the first thing we've got to do is we've got to work in a specific database. In this case, each and every one of y'all will be writing the following line. Use ns underscore your database ID, your my ID. And so you might have something like that, for instance. In this case, that would be your my ID. I don't have that. I do have ns underscore Nikhil, and that is what I'll be using. Now, once we write this SQL, we want to actually execute this SQL. To execute this SQL that we have just written, we are going to have to use either a lightning bolt or the lightning bolt with a cursor through it. Please notice again my cursor is going to hover over them, the lightning bolt or the lightning bolt with a cursor through it. The lightning bolt that we're going to use is the one with the cursor through it. What you're going to do is you're going to place your cursor over the statement you would like executed. In this case, use ns underscore your myid and the line with a semicolon, and leave your cursor there and click on the lightning bolt with the cursor through it. And what happens is that statement, that SQL statement that you have written, is executed, and you will see it executed down below with a successful green check mark next to it. Once that happens, you will notice that your database name is highlighted in black. Another way to execute the same command is to double click on that. So double clicking on it accomplishes the same thing, which is selecting the database that we actually want to work with. The reason we are going to be using your personal databases is you have privileges or the ability to create tables only on your personal databases. The other databases that you see on the list, you do not have privileges to create tables on. Once we have selected the database that we want to work with, move your cursor to a different line, and what we're now going to do is we're going to learn how to create a table corresponding to the entity. The entity that we are going to instantiate in the form of a table is going to be the following one. This one right here, the student entity. The student entity has student ID as the primary key, first name, last name, student GPA, and major. There are some data types for these attributes as well. To create a table corresponding to an entity in your data model, we need to use a specific SQL statement. That is create table. Create table is the statement that we're going to be using to create tables corresponding to entities. Now, please note that any SQL that I write, any SQL keyword like create, like table, like the word use, I am going to capitalize those words. The reason is I want to be able to distinguish between SQL and the names of tables and the names of columns and the names of databases. And so I'm going to be capitalizing the SQL keywords that are involved. The create table statement has a specific syntax or a structure. Create table, I have to specify the name of the table I want to create, in this case, student, have an open, close parentheses, and close it with a semicolon. Within the parentheses, I will be specifying various options. The first option I want to specify is the primary key or the identifier. The first attribute, student ID. And so I specify student ID as the first attribute. In fact, I can specify all the attributes. Now, I am structuring this with every attribute on a new line. You can write this entire statement out in one line, on line number 3 if you wished. The reason I am breaking the statement, this create table statement, up into separate lines is so that it makes the SQL more readable. So I have student ID, I have first name, last name, student GPA, and major. So first name, last name, student GPA, and major. Again, please notice that SQL with the names of entities and attributes is case sensitive. Now, I'm not done yet. Student ID has a specific data type, and that was varchar, and so we want to specify that, and that was 10 characters long, and a comma after that. First name was varchar, 45 characters long, with a comma after that. Last name was varchar again, 45 characters long, with a comma after that. Student GPA was decimal data type, if you remember, 3, 2, and a comma after that. And major was variable character long and 45 characters long. Now, while we have specified that we want to create a table called student with 5 attributes, we are missing one key piece of information. We have not signified which attribute is the primary key. To do that, the last line is going to be this. Primary key is going to be student ID. And that is it. This is our create table statement that we have just written out corresponding to this data model right here, this entity right here called student. Now we want to execute this, so leave your cursor anywhere within all of this SQL right here and click on the lightning bolt with the cursor through it. Aha! Now, while this might work for you, I can see that this has not worked for me. It says it tried to execute this line, and I have an error code 1050 saying that the table student already exists. Obviously, I have been working previously, and I have some tables that already exist, and one of those tables has the name student. In this case, I'm just gonna quickly drop the table. Drop the table actually deletes the table from your database. The way you can do that is you can actually just right click on the table that you want to delete, select drop table, say drop now, and the table should be gone. And so this is me just dropping some tables. Let me go ahead and try to create this table student once again. Clicking on the cursor, the lightning bolt with the cursor through it. There we go. I have a green check mark, create table student. And while I don't see this here right now, if I click on this button right there, refresh, I will see the table called student shows up. And if I click on the bottom arrow and the bottom arrow next to columns, I will see the columns for the table student I created. And so this create table statement allows me to create an entity and define the attributes for that entity or for that table, define the data types of those attributes or those columns, and set the primary key or the identifier for that table.